Hello friends, today we are going to see how to convert a binary tree into a doubly linked list. So let's see. So this is the binary tree, and for converting this binary tree into a doubly linked list, we have to first find out the in-order traversal of this binary tree. So we have to find out the in-order traversal. So what should be the in-order traversal of this binary tree? So it is D, B, E, A, then F, C and G. So if you don't know how to find out the in-order traversal, I have a video on finding out the in-order traversal of a binary tree on my channel. I have mentioned the link in the description below. Okay. Here also I will quickly tell you the shortcut trick to find out the in-order traversal. See, you have to just go on making vertical lines from every node without intersecting that line with other node. See, just make vertical lines and now just follow the sequence of the vertical lines. See, the first vertical line is D, second vertical line is B, third vertical line is E, fourth vertical line is A, fifth is F, sixth C and seventh G. So that is the in-order traversal. This in-order traversal is converted into a doubly linked list. A doubly linked list is a linked list for which every node has two pointers. One pointer points to the next node and the other pointer points to the previous node. Suppose for example B. So this is the node pointer which points to the next node and this is the pointer which points to the previous node. So this is doubly linked list. Now this doubly linked list is in-order based. As you know, we have found out the in-order and then converted that into doubly linked list. But there is another way of converting a binary tree into a doubly linked list, and that way is based on the breadth first search, that is BFS. Okay, look at this doubly linked list. A, then BC and DEFG means A, BC and DEFG. Okay, so this is the BFS of this binary tree and that BFS is converted into the doubly linked list. So this is another way. For now we are going to see how to convert binary tree into a doubly linked list which is in order based. So now first I will tell you the algorithm for in-order traversal. Okay, so this is the 3 steps which we have to follow for writing the in-order traversal of a binary tree, for writing the program for that. So see here, for in-order traversal, for every node in the binary tree, we have to follow these 3 steps. Okay. So the first step is you have to go to the left of a node, then you have to process the node, and the third is you have to go to the right of a node. So let's see in the code how these 3 steps are useful in converting this binary tree to an in-order based doubly linked list. Okay, so now let's see. Convert is the function name and p and head are the 2 parameters passed to this function. Initially p points to the root of the linked list. So p points to the root of the linked list. That is A is the root of the linked list and head is null initially. Okay, so let's go inside the code. Now if p equal to null, return. Obviously if p is null, that means there is no tree, the tree is not present, so we return. Okay, Now we will map these three in order steps in this code. See, the boxes I have made in red are the steps for the in order traversal, and there is something written in between which is an additional code for our purpose, that is converting to doubly linked list. In short, what we are going to do is we are going to use the base program of in order traversal, and inside that program we are going to write some steps for converting binary tree to doubly linked list. Now this is the first step. As I have told you, recursively you have to go to left first, means the first step is go to left. So the function convert is called recursively because we are already inside the function convert, and calling a function inside itself is recursion. So I say that this function is recursively called with the left child of the root, that is p. P is now pointing to the root. Okay, so first we go to the left. Then the second step is process the node. That means do whatever the process you want to follow for your purpose, means for conversion to doubly linked list. So this is that process for the conversion. Okay, that is the second step, and this is the third step. The third step is go to right node. So we are calling the function convert recursively and we are passing the right child of p. Okay, the right child of p. So these are the three steps which are going to be executed for every node in this binary tree. So I will write the three steps for every node of the binary tree here. 1, 2, 3. Again 1, 2, 3. 1, 2, 3. I will write it for every node. So I have written the numbers 1, 2, 3 for every node, so that we will perform each step for every node in the binary tree. If you have seen my previous binary tree videos, then you will perfectly understand this. Okay. Now let's look at the whole code. So first part is we check whether the tree is present or not. Then the next line is static node star previous equal to null. So this is a variable, that is previous, which is related to forming the doubly linked list. That means whenever we are at a node, suppose now we are at a node B, then the previous node points to node D, that is the previous of B. Okay, so that is its purpose here, and the reason why it is static is that we want only a single copy of this variable for the whole recursion tree. Okay, for other variables, every node in this recursion tree is going to get the copies of the other variables, means there will be multiple copies of the other variables, but for this variable, that is previous, there will be a single copy of the variable for the whole recursion tree. Means if any node updates that variable, then the update directly occurs in that single copy. Okay, now let's go to the next line, that is the first line of in order traversal. So now as we are at the root, the p points to the root, we have to go to the left of that node, that is p, and the parameters passed are the left child of p and the head node. So now p will go to the left of a. Okay, now p will point to b. Okay, because from here we have passed the left node of p as a parameter. So now b comes here, the address of b. Okay, and head is null, so again null comes here. Now For B, again checked whether it is null. No, it is present. It is not null. Again, as this node is static, so there will be only this copy of that node. And now again we go to the left. Let's go to the left. So P will now point to D. Okay. So again we come here. Now D is passed as a parameter. So again it is not null, previous is declared, and P points left. So we go to left of P. So left of D is null. Nothing is there means it is null. So P is pointing to null. Okay. So now when null comes here, because the left of D is null, so null is passed as a parameter. So this condition is satisfied, that is if P equal to null. So we return, okay, we return back to the parent. So we come back to the parent D. That means our first step is over. So the first step at node D is over. So we have to go to the second step. And second step is processing the node. So let's process that node. See, if previous equal to null, head equal to P. That means as this node, the leftmost node, is the first node in the in-order traversal, that means that is also the first node in our doubly linked list. Okay, and the first node we refer to it as the head node. Okay, so the first node, see here, everything is occurring in place, but I am just writing these nodes here for giving it a look of doubly linked list. Okay, so this memory location I write it here, that is D. So that memory location is holding the character D, and D is the head node because the previous is null. Obviously, if it is the first node, then the previous node will be null. So that is our condition to check whether it is a head or not, by checking whether previous equal to null or not. Now as if condition is satisfied, we will not go into else, so we will directly go to this line. Now previous equal to P. So for the next node, whichever is going to come here, the next node here, for that node previous is the current node, right? The current node which we are going to process, it will be the previous node for the next node. So before going to the next node, means the next recursion, we make the current node as the previous node. Okay, so this node becomes the previous node. Okay, now let's see, convert P points right comma head. So that is the step in the in-order traversal. So as here, see, the first step is over, we went to left, then we processed the node, so the second step is also over. Now the third step is remaining. So let's follow the third step. Third step tells us to go to the right. Okay, as there is nothing to the right means there is null. Okay, so as null is passed again in this recursion, null is passed because right node of P is null. So null is passed. So again this condition is satisfied, P equal to null, return. So we return to the parent. Okay, for D, as all the three steps are over, means 1, 2 and 3, all the three steps are over, means we come outside the function. Okay, we come outside the function. That means we come outside the recursion for D and we return to B. Okay, because we came to D from its parent B as the first step. See, for B the first step was to go to the left. So we went to left D. Now when we return from D, as the first step is over for B, Now we will go to second step. Okay. Now the second step again is processing the node. So here is the steps. If previous equal to null. Is previous null? No, previous variable is not null. So this if condition does not satisfy. Now in else. So here p points left equal to previous. Okay. See what is p? P is here b now. Okay. So I write b here. Everything is in place. I am just writing these nodes here. Otherwise no new memory location is assigned. Okay. So this is b. So that is p. Now p points left equal to previous. So now here for p points left equal to previous. So the pointer left pointer of p will point to previous and previous points right equal to p. So this previous point right equal to p. Okay. See, for a node there is a left pointer and a right pointer. Right pointer points to the next node and left pointer points to the previous node. That is as easy as that. Okay. So now as we are finished with these steps, previous equal to p. So now as the current node is this node and we are going to finish the processing for that node. So now the current node will become the previous node. Okay. So now the third step is convert p points right comma head. So here see, for b the second step is over. We are going to the third step. So the third step is going to the right. Now we will not see the code. We will directly perform the steps here as you remember these steps now. So now let's go to the right. For e the first step is go to the left. Left is null. So come back. Then the second step is process the node. So e is the node. Okay. So p is pointing to e now. So what we have to do? P points left is previous and previous points right is p. Okay. This step is over. Now the current node p will become the previous node. Okay. So this is what we have to follow till the end. Now as second step is over, let's go to the third step. Let's go to right. But right is null, so return from there. Now all the three steps are over. Return to its parent. So we came to b. At b also all the three steps are over, so return. Okay. So we went inside the left side of a as the first step. So as the first step is over, we have come back from the left subtree. So as the first step is over, now we will go to the second step. Okay, what is the second step? You have to process the node is the second step. So a. Now p is pointing to a here. Okay, so as p is pointing to a, p points left we have to make as previous and previous points right we have to make it as p. As this node is processed, now we will call it as previous node. Okay, I'll just clean it for writing the remaining nodes. Now at a, as the second step is over, let's go to the third step, means we have to go to right. At c, let's go to the first step, means we have to go to the left. For f, let's go to the first step, means we have to go to the left. As left is null, we have to come back. Now first step is over, let's follow the second step. What is second step? P will point to f here. So p points left is previous and previous points right is f. Okay, as second step is over, let's go to the third step. Third step is going to the right, so that is null. So come back. As all the three steps are over, return to its parent. At c, the first step is over, so let's go to the second step. Second step is processing the node. So p is pointing to c now. Okay, So P points left is previous, previous points right is P. Okay. So for C, as the processing is over, the current node will become the previous node. Okay. Now, as two steps are over here, let's go to the third step, means going to the right. At G, let's follow the first step, means going to the left. As left is null, let's come back. Then go to the second step. Second step is processing that node. So let's create that node, that is P. Create means I am just writing it. Actually, the same memory location where G is stored, that memory location is used. This algorithm is totally in place. Okay, there is no new memory location is created. So P is pointing to G. So P points left equal to previous and previous points right equal to P. Okay. Now, as the second step is over, let's go to the third step. Third step is going to the right. Right is null. So let's come back. Okay. All the three steps are over. So let's return to its parent. So here also all the three steps are over. So let's return to its parent. Here also all the three steps are over. So we return from this code. We return to the main function from where the function is called. Okay. There is a question for you. You will ask, what about the null here? And what about the null at the end here? Okay. What about this null and this null? So the reality is that these nulls are already there. Actually, see, for node D, the left pointer is null and the right pointer is null. But for this node, we have changed the right pointer. See, this is the right pointer. So the right pointer of this node is changed, okay, to B, and the left pointer is not changed, means it already points to null, and that is permanent here. That already points to null and it will point to null forever. Okay. And for this node, you can see here, see, for G, the left pointer is changed. This left pointer is pointing to C, but the right pointer is not changed, right pointer. So that is pointing to null already, and now also it points to null because we have not changed those pointers. Left pointer for the head node and right pointer for the last node. That means these nodes which are having the left and right pointers, these left and right pointers are now assigned new memory addresses, and the new memory address assignment has made them or has converted them into this doubly linked list. For each node there is a left pointer and right pointer. As you know, for every node in the binary tree there is a left pointer and right pointer. Only thing what we have done, we have changed the memory addresses in a way that converts this binary tree into a doubly linked list which is in order based. In short, we have written the code for in order and we have just written the code for processing the node inside that in order node. Processing the node means what? Just changing the pointers. That's it. So this is how we have converted the binary tree to doubly linked list, and the time complexity is O of n because we are visiting every node once. So n is the number of nodes and the time complexity is O of n. Hey friends, please subscribe to my channel as I post algorithm videos every day. And if you want a video on any particular topic, then please mention in the comment below. Thank you.